And welcome to the last problem of section 6.1. Consider the arc below. How wide, and so we've got an arc here that's 24 feet long, and at the top, at its maximum height, it looks like it's 20 feet tall. How wide are the two sides of the arc when it is, or arch, when it is 18 feet above the ground? So how wide is it when we are 18 feet above the ground? So here is 18 feet high, and you can see that the question is asking how wide are the two sides when this distance up and down is 18 and 18 instead of 20. So that's going to be kind of tricky, and what we're going to need is the equation for the parabola. So the key to doing a problem like this is being really smart where you put the parabola on the xy axis. You want to put it in a place where it's going to work out really nicely, and here is the best place on this problem to put it. I would put it so that the maximum distance, that 20, occurs on the y-axis, and we come down this way and down this way. And so in other words, because we're 24 feet along the bottom, this point is going to be 12, 0, and this point is going to be negative 12, 0. That, I think, is the best positioning to put this on the xy axis so that we get the most canceling and the most zeros and stuff. Because remember, we need an equation for the parabola, and guess what we have if we do it like this? We have the two roots. Do you see that? The two roots? And so that means the equation would be y equals, okay, and it's going to be a times our first root, which is x minus 12, times our second root, which is x plus 12. You should kind of remember that back from chapter 3 when we were doing solving polynomials. So there are two roots, 12 and negative 12, which means the only value we need to find is a. So let's simplify this a bit. If we FOIL the right side, we get a times x is x squared plus 12x minus 12x minus 144. So there's our equation right there. The 12x's cancel. So we get y is equal to a times x squared minus 144, or y equals ax squared minus 144a. So all I did on that last step was just distributed the a. So we have y equals ax squared minus 144a. So we almost have the equation of the parabola, except that we don't know what this a is. But we can figure that out because we have one other point on our parabola, right here. This is the point 0, 20. In other words, when I plug in a 0 for x, I should get a 20 for y. And so let's do that. You see we have the x here. If I get 20 for y, plug in a 0 for x, so all of that goes away. There's no x right there. So it's 20 equals negative 144a. Do you see how that was really tricky? I plugged in a 0 there, so all of that went away, and I plugged in a 20 here because the point 0, 20 is on the parabola. So divide both sides by negative 144, and that will be a. So a is approximately, let's do that in our calculator, 20 divided by 144 is 0.138888. So, and it's negative, so negative 0.13888. I'll say 889. So now we can go back to here and have our equation. So I'm going to plug it into this one right here. So our equation now is y equals negative 0.13889 times x squared minus 144. And notice the a is negative, which is good because we needed the parabola to open down because that's how we did our drawing. So that's really good news that a is negative. And if a was positive, maybe something weird is going on. We actually now have enough information to solve the problem. Because what did it want? It wanted a height of 18, and it wanted to know what values of x give us a height of 18. So in other words, you just plug in 18 for y and see what two x values give you that height. So let's plug in 18 for y. So 18 equals negative 0.13889 times x squared minus 144. We plugged in the y value, and now we're going to find the x value. So let's do 18 divided by 0.13889 negative. So we get negative 129.5989 equals, so we divided both sides by 0.13889 to cancel. And so now that gives us negative 129.5989. I guess I'll add the 6 so that we don't have to worry about rounding. Equals x squared minus 144. Okay? So now we just add the 144 over, plus 144 plus 144. So we get 14.401 is equal to x squared. And then the last thing to do is to just take the square root. So let's take the square root of that number. And we get 3.794. So let's round that. So this value right here is 3.795. And remember, we get positive and negative when we take a square root. So 3.795. So the other value here is negative 3.795. But let's think about what the question was asking us. It said, how wide are the two sides when it is 18 feet above the ground? So in other words, we need this total distance right here, the distance between the two sides. And so all you have to do is just multiply this by 2 for the final answer. So the answer is 7.5897 feet. So that's kind of a tricky problem, so that's why I wanted to just show you how to do it all. The final answer is 7.5897. And again, that was just 2 times the x value that we found. So you see that the key is putting this on the grid in the right place. Here's potentially another way you could have done it, just real quickly. If you put the parabola right here, so that one root is at 0, this root would be at 24, and then this maximum height would be at 12. That might be another way of doing it, and you'll get a different equation, but it should simplify back to this equation once you're done simplifying and working it. So sometimes you just got to play around with it until you get a good way of representing the parabola to come up with the equation. I hope this was helpful. I hope you like parabolas. Next section is on ellipses, which are a little bit easier, I think, than parabolas. If you have any questions, please leave them in the comments. If this was helpful, please remember to like and subscribe, and I will see you in section 6.2. See you there.